Hi, in this tutorial I'm just going to introduce ncloth. ncloth is Maya's cloth simulation module, and it takes, if you turn anything into an ncloth, well, specifically a polygon object, it turns each of its vertices into a particle that's linked to the other vertices around it, or the other particles around it. And then when you submit it to force, it will deform accordingly to the properties of cloth that you set for it. So it's a very stable and fast cloth solver. But you should know from the outset you can do a lot more with it than just simulate cloth. It can be used to simulate metals, all types of different cloth, different thicknesses, different types of properties, all the way up to very fluid-like materials. So it's very flexible, and it's quite useful for the type of work that we do. But here I'd just like to go over some of the basic elements involved. So I've got a simple piece of geometry with a texture on it. You don't have to have a texture on it, but makes it a little more interesting. Um, and I'm just going to take it. I've deleted the history already, and I'm going to go to ncloth, create ncloth. Now, if I play my animation now, go back to the beginning, you see it just drops down through there, and you can see it's starting to ripple a little bit. I've got some wind in this scene, but it just drops straight away. So we have to make it stick into into its where it's hanging now, and we can do that by using what are called n constraints, not to be confused with Maya's normal constraints. So down here we've got n constraints. I'm not going to go through all of them right now, but we'll just use one that's probably the most important or the most generally useful, is the transform constraint. So I can just right click on my object and select a couple of vertices and apply a transform constraint. You can see that a new locator is created here. When I have it selected, it indicates the vertices that belong to it. When I select the ncloth object, you can see they turn purple, so there's a historical relationship between them. I'm just going to turn off something here. And now when I play the animation, I'm going to turn off my grid. You can see that it tries to fall, but it's constrained to these two vertices are constrained to this position, and because all the others are linked, it stays there. So not too interesting so far, but you can see that it's starting to deform and it's responding to gravity. So the gravity is preset here. Now let's look at the different nodes that go into an ncloth object. So let me select it. If we look in the attribute editor here, you can see there's an ncloth shape node here, and this is probably the one they'll be using with most, and this is the one that defines the qualities of the cloth itself. I won't go through all of these right now, but you can go down and take a look. The thickness of the object, it's how it collides with itself, how bouncy it is, how much friction it has, how sticky it is or slippery it is, its mass, its lift, how it will respond to air density, the drag, which is how it responds to environmental variables that will slow it down, that will cause inertia to occur, that will tend to reduce the effect of forces on it. We can talk about tangential drag later. Just pretty straightforward things like stretch resistance, compression resistance. So something like silk will have a high stretch resistance, whereas something like honey will have a very low stretch resistance. So you can set these to change the values, and so on and so on and so on. And we'll talk about all these things later. But the best thing to do just to get started is to look at the presets that Maya has built in here. So you can see that there are all sorts of things going from t-shirt to water balloon, putty, rubber sheet, and so on, concrete. And see what it does to the settings and see how it changes its reaction to forces in the world. But before we get into that, the other really important node here is the nucleus node. So if the ncloth shape defines the qualities of the cloth itself, the nucleus node defines the qualities of the world in which the ncloth exists. So that's where we find the gravity, things like air density, how thick the air is. It will affect things like lift, a sort of a global wind attribute, um, and a whole bunch of other things that have to do with how ncloths collide together, and a few other things that we'll talk about in later tutorials. In addition to that, there's another node called an output cloth, and so this is after the ncloth is applied. This is the actual shape node that will is that is actually deformed. There's also an input mesh that we'll talk about later, which is just your original geometry. So we can test some of these things if I just go into the nucleus node here, and under ncloth you can turn on interactive playback, and I'm on play every frame now, and you can see I've got lots of frames to work with here. So turning on interactive playback, now I can do things. I can experiment with changing settings on the fly. So in the nucleus node I can turn up the wind speed a little bit, so you can see the wind is blowing in the Z direction. I've got it set to Z. And turn up things like wind noise, and this adds turbulence to the wind. So there you can see it start to deform like that. I'm going to stop it and just go back. And that's the default ncloth settings, but I can go in and change them to something like silk, which would be probably quite similar. Silk is, you can see it's got more lift. It's lighter material, so it's lifting more. And it's also much more stretch resistant. But I can go back and I can change it to something like chainmail, which can be compressed but won't stretch it. And it's much heavier. Mass is set to 10, so the wind isn't doing nearly as much. If I go turn on interactive playback, I can try and turn up the wind until it actually blows. It's not giving you as much reaction to the noise either. It's much heavier material. But you can do things like lava or honey. Honey will be very stretchy. This may actually go a little bit crazy. Yeah, so there's no stretch resistance here. So it's dripping like honey. Nice. Looks like Wolverine. Anyway. So you can go in and put it to a setting that is close to what you want. Maybe I'll go back to, or something. If you look at this like soft sheet metal, it'd be much more rigid, but if it does deform, it's likely to keep that shape. Whereas cloth will be more likely to go back to its original shape. If I turn the wind speed way up, no, I probably can't. I can't get it enough to I'm trying to bend it until it stays in that position, but it's not going to deform enough. But so you can have deformable objects that, if they're deformed past a certain point, will retain that shape, like a piece of sheet metal that's bent. So you can do a lot of things with it. So when we come back, we'll start looking at some more advanced ncloth settings, but the best thing to do with this sort of stuff is just to go in and play with it. Create a shape, turn it into ncloth, and just start changing some of the settings around and see how it reacts to different things. The one thing I should say before I end is that you can see it's a fairly low resolution piece of geometry, and that's fine. In fact, when you're working with this, you want to keep it as low as possible, but with enough resolution so it can deform in interesting ways. And if you need it to be smoother after, add a smooth to the object after the ncloth is applied. So now I could go in and go to Mesh Smooth, and that way it will still simulate quite quickly, but it will render more smoothly. If you put the smooth on before, it will really slow down your simulation times. Okay, so get in there and try it out, and I'll come back with some more interesting things you can do with ncloth.